Hello, is it visible? Screen is visible.
Yes, sir.
So in the previous class, we have discussed about the introduction of the potentiometer, how the voltage is dividing for the different lengths based on that. So the voltage is directly proportional to the length of that particular cable or wire. We have proved that one. We have proved yesterday. In our previous class, we have discussed that. Today we are going to discuss about the basic slide wire potential we are going to consider here. Slide wire potentiometer here. Slide wire means that is flexible, we are going to call that one here. See, if the conductor is this is here, this is the conductor is there. Okay, from here to here we can fixed value is there. The length of this one is fixed, we are going to use here. That is called conductor here now. Only which is having uniform cross-sectional conductor we are going to consider. So one point I will keep this one as fixed connecting to the one point here now. Another point what I will consider, instead of connecting here, I will make that one as variable here. Now I can connect here by like a variable resistance. We can shift that one. We can use that. That is a slide wire we are going to consider. Its terminal is here. From here to we have to connect. We can connect anywhere in between to that. So this point here I can connect, here I can connect, here I can connect. So that is called slide wire potentials. We are going to call that one here now. So same diagram, whatever we have discussed in the previous class, same diagram with the slide wire we are going to discuss here now. 826. Still some people are joining. See here the battery supply we have considered. The battery supply is considered here, and we have used one uniform cross-sectional area. The conductor we have used here now, that is which is having a uniform cross-sectional area here now throughout that length here now. This is A, I can consider. This one I will consider as B here now. It has also some scale also here now. Here see here 0 to 50, 50 to 100, 100 to 150, 150 to 200 we are going to consider here. So this is the cable. We have to calculate the total length of the cable is A to B. A to B length is there. I have to calculate here what is the value of voltage from A to C. From C to D how much voltage is there. D to E how much is there. Like that we have to calculate the voltage value. And the previous class I have given some examples also. The bus pay charges. I have concluded that. I have already given the examples for that one. So here the battery supply is previously we have considered here now. So the positive negative of the battery supply is connected to the point A of a uniform cross-sectional wire here now, conductor, which is having the length of that conductor is A to B here now. LAB we can consider here now. The negative supply is connected to the A terminal, and the positive of the battery supply is connected to the B terminal through the variable resistance or rheostat we are going to consider here now. See, this resistance is variable. Why we have to use this variable resistance? To make this current, working current, to be constant here. Now we have to get 5 ampere means by varying this one, by increasing this resistance, variable resistance, we can set the exact current value. It may be exactly what is the standard resistance is there. Based on that, how much 5 ampere, 2 ampere we can set by varying this resistance here. All of you, what is the relation between resistance and current? Resistance and current. Can you tell me the formula, anyone? Is it directly proportional or inversely proportional? R and I. Is it audible?
Yes, sir.
Proportional. The current is inversely proportional to the resistance here now. So if by increasing this resistance, we can reduce the current. By decreasing this one, we can increase this current here now. So the working current, to limit the working current or to set the working current, we are using a variable resistance, that is called rheostat we are using here now. So positive is connected to the terminal B of the conductor and negative of the battery supply is connected to the positive E of the terminal over there. Okay, so this is one circuit, this is one part of the circuit here now. Second part, we have to consider here, I will not fix this one here now into C. At this point only I cannot fix here now. This sliding wire, it has two terminals, one is fixed one, another one is we can vary here only, we can vary here only here. So that is slide, we can slide this wire from here, some distance we can vary over there. So that is the sliding contact, we are going to call this one here. Okay, and the one switch we have used, that K switch, that is to close the into sliding content or contact. To the galvanometer we have used one switch here now, and the galvanometer is connected in between the K and S switch here now. The switch S, it has three terminal, one is connected to the galvanometer, another one we can use for the operating mode or we can use for the calibration purpose here now. In the calibrating mode also we can use here now. Here the unknown, if we are going to operate here, means it is we are going to measure the unknown EMF here. This unknown EMF can be measured if it is under operation mode here. If it is operation mode, so it is also connected to the negative terminal of this one here now. So if the switch is yes closed here now, and when I will close the K here, so it will take the supply. It is also closed conducting path only. It has two parts. Listen carefully. This positive, the current will start to flow here. So we'll set the working current here. Now once the working current is set, so the current will start to flow here now. Current will start to flow through this 0 here now. It is one part. Here the sliding contact is there. So if it is open, then no current will flow here. No, all the current will flow here. We cannot measure the unknown EMF here. Here the voltmeter is there. Okay, unknown EMF we are going to measure here now. So if this K is closed here now, some current will start to flow here now. Through a galvanometer, it will flow through the unknown EMF and we are going to close, it will be closed circuit here now. So if the galvanometer is detecting some value, then we can say that the unknown EMF is not correct, that one. It should be, make it as 0. We should have to detect null detector, we are going to call that one. Galvanometer should be detect null here now. It should not detect any values. On that condition, the unknown EMF we can measure. We can note down that value. Can note down that value. Just a minute. So we can measure the unknown EMF here. That is operating mode we are going to call here now. But what is the potentiometer definition here now? We have to measure the unknown EMF and compare it with a known value here now. If it is correct or not, we have to compare with a known value here now. How will get the known value? That is called calibration only. We are going to get that one, that is calibration only. We are going to compare with unknown value measured, then it is correct or not, we have to measure, means that is called calibration we are going to call here now. To calibrate that one, what is the value is there here? Same value, the standard cell we are going to use here. Now we have to give the supply here. So that one, the S switch is should have to shift into calibrate mode. On that condition also it should have to show the null detect only here. Then the value is correct, we have to assume that here now. That is for the two terminals are there, one is for the calibration purpose, another one is for operation purpose here now. So this just I have told here now, construction and working both are mixed here now. So one by one we'll discuss here now. See, this is the construction of the slide wire potentiometer, that is a DC potentiometer only here now. So this potentiometer, it consists of long uniform wire here now, that is a uniform cross-sectional wire, cross-sectional area wire, which is made from manganese material here now. This thick line, it is visible, dark line, that is the wire we are going to consider here now. Okay, long. The basic slide wire potentiometer consists of a long uniform slide wire AB made of manganese material here now. This one we have used manganese material we have used here now. A graduated scale runs parallel to the wire. Where is the scale here? This is scale only, na? 0, 50, 100, 150, 200. It is scale or not? Yes, it is a
Yes, sir.
drawn on that one. Parallel we are taking the wire, which scale we are going to use here now. So I told that one, the terminal A is connected to the negative supply and terminal B is connected to the positive supply through a rheostat here now. So the end of A is connected to the negative terminal of the battery, whose positive terminal is connected to the end of B through a rheostat. It is connected here. So the positive terminal of the standard cell is connected through S switch here now. This positive terminal is connected through the, which is standard cell we are taking here now. This is the standard cell. The positive terminal is connected to the switch S and negative is connected to the this one here now. Negative terminal we are going to call that. The positive terminal of the standard cell is connected through the S and S to galvanometer, galvanometer to key we are going to call that one, key switch, that is K here now, to a slide contact here now. This positive supply is connected to here now. So the working of this, how it is going to operate here now. When this switch is operate mode, it is operate mode. I told that one, to measure the unknown EMF, we have to put in the operate mode. To compare with the standard value, we have to put in the calibrate mode. Two modes are there. One is operate mode, another one is calibrate mode. So working, we have to push the switch yes to be in the operate mode. Okay, which switch yes is in the operate position, the galvanometer key, that is key, this key is open here now. This key is open and the battery supplies a working current here now. This is the working current here now. This working current is depends on this variable resistance here now. By changing this one, the working current will changes over there. So the battery supplies a working current through a rheostat and the slide wire here now. The working current will start to flow here. So the working current through a slide wire may be varied by changing the rheostat setting here. Now we can set the value here now, but while doing the calculating the unknown EMF, we cannot change the resistance here. Now we have to pass a constant current throughout the cable or throughout the length of the wire here. Okay, so the method of measuring unknown voltage Vx depends on finding a balance point on the sliding wire here. What we have to do, we have kept this one into operate mode now. So we have to close this K into the sliding contact here now. It is also closed conducting path now here. So by making this sliding contact, by varying this one, we can make the null detector here now. Whatever the value is there, we have to, it should be made to bring to the 0 here. If it is null detector, then we can find out the unknown EMF. That is the value of unknown EMF. We can tell that one here. The balance point of sliding contact such that the galvanometer shows 0 deflection here now. We have to vary the balance point, that is sliding contact, to get the 0 deflection from the galvanometer here now. There is no current in the galvanometer when K is closed here now. K close karne ke baad, if it is no current is flowing here now, the galvanometer is detecting null, then we can measure the unknown EMF here now. So 0 galvanometer deflection or null means that the unknown voltage Vx is equal to the voltage drop portion of AC of the A to C here now. This is A, this is C here now. So voltage drop across this unknown EMF is equal to the voltage drop across this A to C terminal. We can say here now. We can say that one here. So the slide wire has a uniform cross section and hence uniform resistance along its entire length here now. Along its entire length, it has uniform resistance here now. Whatever this process of is there, standard cell and calibration process, that is called standardization, we are going to call here. How it is going to, the process of adjusting the working current here now by varying this one. The galvanometer means it is a null detector. Null detector means current only we can measure here now. Current meter we are using here now. So by adjusting this one, we will bring this one to 0 here now. The process of adjusting the working current by changing the resistance here now. The length is resistance. Resistance is directly proportional to the length. We have proved that one. R equal to rho L by A. In the starting first class itself in the potentiometer. So by varying this the length, resistance will vary. So by varying that one, the current will be changes here now. So by adjusting the working current, this working current by adjusting so that so as to match what we have to match, this voltage drop of this unknown voltage should equal to the standard cell voltage here. Should have to match voltage drop across the portion of sliding wire against a standard reference source is known as standardization here. Whatever this, by varying the current here now, by varying this length, the current will vary. By varying this one, we can bring the galvanometer into 0. So we can measure whatever this, we can compare that the measured value of unknown EMF should equal to the standard reference value here now. That is called, the process is called standardization, we are going to call it. Standardization we are going to call here now. Okay, example I will give one more example what I have to give. Okay, in your class total class strength is 44 is there. Yes, total class strength kitna hai? The roll numbers allotted for you people is 44 students are there. Okay, yes or no?
Yes, sir.
Okay, you just think that one, all of you are paying 1 lakh rupees here now. Every year you are going to pay 1 lakh rupees. 1 lakh rupees fee you are paying to the college here now. So total per year how much it is? 44 lakh. 44 lakh the we are getting from you peoples. Yes, just think that one. So after ending, we are expecting that 44 lakh we have to get here now. Every year we have to get here now. So after completing your second year, what will happen? Some students, they will fail here now. Nearly about 14 students, they will fail. Only 30 students, they are going to enter into the final year. So then also you people's total, you are going to give the 44 lakh. 30 student, you will give 40 lakh.
No.
No, how you are going to divide then? First student only you are going to divide, na?
Yes,
Not matter how much strength is there in the second year and all this. This 44 is total number of students, but 30 is after the net output here now. Only for 30 we have to calculate for the final year. Only 30 we have to get the final year here now. Like that. One more thing, one more example I will give here. I am not getting actually what I have type examples I will give. So you are going you are going to Solapur by buying a car here now. You are going to Solapur by buying a car. You just think that now Mumbai, one person is going to Pune, another person is going to Mumbai here now. Two persons are there here. Pune and Mumbai, two persons, they have going by a vehicle here now. Car se they ja rahe dono. So they are sharing the car rent here now. They have taken a car by a rent here now. Whatever the charges is there, they are going to share here. So the Pune is how much kilometer? 200 kilometers away from the Pandharpur. The Mumbai is 380, around 400 kilometers away from the Pandharpur here now. What is the total kilometer here now? What is the total kilometers from Pandharpur to Mumbai? How many kilometers here now?
600.
Huh? 600. 0. Pandharpur to Pune for 200. Pune to Mumbai 200. How much it is now total?
400.
Total. Total 400 kilometer. Per kilometer, he is going to charge as 10 rupees. Just imagine 10 rupees here now. So the total kilometer is 400 into 10. How much it is? 4,000 rupees. Yes, total is 4,000 rupees. Total is 4,000 rupees here now. So they are going to divide, means one person will get 200, another person will get 200 here now. Yes, 2,000, 2,000 they are going to divide here now. They are going to share that one. But one person, he is not going to the Mumbai at all. Only one person is going to Mumbai. So this is the middle. So 0 to 200 kilometer is there. 0 to 200 kilometer. So he will pay half for 200 kilometer only. Two persons they are going to Pune. दो लोग जा रहे हैं ना पुणे को.
Yes, sir.
So according to UP bus, they have to 2,000 rupees each person they have to pay. But another 200 kilometer he is not at all taking the journey here now. Only 200 kilometers he is taking journey here now. 200 into 10, how much it is? 200 into 10. How much it is? अरे बाबा इतना भी 200 into 10 I am asking.
2,000.
2,000 rupees here now. So here how many persons they are going here from Pandharpur to Pune? 2 persons are there. So divided by 2, how much he have to pay? One person has to pay 1,000 rupees. One person has to pay 1,000 rupees. Another person has to pay this 2,000 plus this 1,000 here now. So from the Pune to Mumbai, full 2,000 rupees he has to pay, plus Pune to Pandharpur to Pune 1,000 rupees. One person has to pay 3,000 here now. So based on according to the per kilometer, so according to how much journey he has taken, based on that only they are going to pay. Like that, total length is 0 to 400. Total length is 400 kilometers is there. Like that, total length is here A to B is there. So I want to measure the only, what happened? I want to measure only the voltage drop across this one. I want to measure here. So total is not necessary here now. How much we have to do here now? So suppose ये per kilometer मैंने charge किया. Suppose just one more example I will take. Two persons they are going to Mumbai again. पुणे को एक आदमी जा रहे हैं, मुंबई को जा रहे हैं. वो किलोमीटर वाइज काउंट नहीं किए, डायरेक्टली क्या किए? 4,000 रुपीज को वो बुक किए, वो एक कैब बुक किए. That is called 4,000 rupees. So what we have to do to get one person calculation here now? Total amount is 4,000 divided by 4,000. What is the total kilometers? Total kilometers how much? 400 kilometers we have to do. So per kilometer how much charge we will get?
10 rupees.
10
10
rupees. So per kilometer 10 into what we have to do? Into how many kilometers they are journeying here now? So into that around 200 kilometers they are traveling here, means into 200 here. I want to calculate the charges for up to 200 kilometers only. This 4,000 is, we have booked a cab for 4,000 rupees to the Mumbai, but we will cancel the plan. We have to move. We are planning to go up to Pune only. Then we have to pay 4,000.
No, sir.
Only up to 200 only we have to Pune only we have to pay, na? So total for Pandharpur to Mumbai is 400 kilometer, but we are going for up to Pune only. So 4,000 को हमने book किया था, 4,000 divided by 400, that is per kilometer 10 rupees. How many kilometers we are running? 200 here now, equal to 2,000 only we have to pay here now. Like that, the potentiometer, what it will do, total voltage drop across this one A to B here now, that one it is going to consider here now. VAB equal to what we have to do? So divided by LAB we have to consider here now. What is the total length we have to consider into VAC, how much voltage we have to consider here. So the unknown voltage I am going to tell you. Unknown voltage is total voltage, total VAB divided by VAB divided by LAB, total length go, into how much we have to get? This one only. VAC or LAC we have to multiply here. LAC we have to multiply. VAB divided by, this is total voltage drop across A to B, total कितना है उसको total length को divide करने का, per meter को we will get that one, so into 100 meter we are doing is, that is 100 we are going to get here. Like that we have to prove, we have to calculate here now. So this is the formula we have used. Mathematically from the figure, the working current IW equal to, that is called Rn plus LR, they have used that one, leave this one, this formula we will use that one. We will use two methods we are going to use, one is standardization, another one is calibration we are going to do here now. So this one for the total source voltage, this is for the unknown voltage here. This is for the total source voltage, this is for the unknown voltage here now. The source voltage equal to IWL1 into R. The uniform cross section, I told that one, this length has uniform cross sectional area, so throughout the length it has same resistance we have considered here now. So this A to B, that is L1 we are going to consider, A to C we are going to consider as L2 we are going to consider here now. So IW is the working current, the length L1 into R we are going to consider here now, and for the unknown voltage IW is the working current, L2 into R we are going to consider here. From this formula you separate that one, IW equal to, what is the formula IW equal to? By considering this one, IW equal to VS, this RHS side I will into send it into LHS side, it will go to the denominator, VS divided by L1 into R. VS divided by L1 into R we have written here. IW equal to VS divided by L1 into R. Similarly, we can write here also working current ka formula nikalo, IW equal to VX divided by L2R here. IW VX divided by L2R here. See here the LHS, what is the LHS of the equation number 1? Here also IW is there, here also IW is there. Directly we can make the two equations equating, or you can make that one equation 1 divided by equation 2 also we can make that one. Equation 1 divided by equation 2 by doing that one. So this LHS will be IW by IW, that is nothing but 1 will get here now. VS by L1R, VS by L1R, VS by L1R equal to VX by L2R we can calculate here now. See, what is the formula for 1 by 2 divided by 1 by 2? Not divided by 1 by 2. 1 by 3 here now. What is the formula? 4 by 3 I will write here now. 1 by 2 divided by 4 by 3. You can write this equation into 1 by 2 into 3 by 4. Into 3 by 4. We can write like this.
Yes, sir. Yes, sir.
Yes or no? Some persons they are telling no, some persons they are telling yes.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
So this one like that, 1 by x, that is called equal to x only, na? 1 divided by 1 by x, that is called x only. 1 divided by 1 by 2, that is called 2 only. Like that we have made this formula here. Now here also it is the same thing only. Vs by L1R I will write as it is here now. This term will become numerator into denominator, denominator into numerator here now. So L2R divided by Vx we are going to get here now. So here also L is there, here also L is there. So this is the only one term here now. Vs L2 R divided by L1 R into Vx here now. So R get cancelled here now. So the term left is Vs by Vx divided by L1 by L2 by L1 here, L2 by L1 here. From these equations, what we can write here, we can write Vx is the unknown voltage here. Now Vx equal to total source voltage divided by total length L1 into the whatever the required length here now. Unknown voltage up to this length is there, that length we are going to consider here. So that is called Vx, the formula for the measuring the unknown voltage we have told here. Unknown voltage we have told here. So L1 is total length, L2 is only up to that point only we are going to consider. Up to that point we have to consider here. So that is called the unknown voltage formula. It completes the slide wire potential diagram here now. So if you have any doubts, you can ask that one. See example, many और भी examples. Last time which example I was given? Petrol I was given, na? The petrol rate or bus fare I have given that one. Up to Solapur, how we want to go. The bus is going from Pandrapur to Solapur. Pandrapur to Solapur. So the bus fare is 100 rupees for the Solapur. But you want to go to the Mohol only. So they will not charge you to 100. They will not charge you to 100, no? They will charge up to Mohol only. Yes or no?
Yes, sir.
They will not charge to the up to Mohol. How they are going to calculate? Total from here to here 100 rupees is there. Total kilometer कितना है? वो भी क्या calculation करेंगे, रुको अभी. How we are going to consider here now? What is the distance from Pandrapur to Solapur? Can you tell me? Around 70 kilometers. Yes.
Yes, sir.
70 kilometers is there. Okay. So the bus fare is how much it is? 120 or 100? Okay, 140. I will consider this one here now. 140 rupees bus charge is there from Pandrapur to Solapur here now. So the bus is going from Pandrapur to Solapur. The bus is going here now. This is Pandrapur. This is Solapur here. Okay. So I want to get down at Mohol only. What is the kilometer of Mohol? कितने किलोमीटर है Mohol? Around 40? Yes?
Yes, sir.
40 kilometer का है. हमने, I don't know how much charge is there. How to calculate this charge of this one here now? Can you tell me what is the, by considering this one, up to Solapur 140 rupees is there for 70 kilometers. For 40 kilometers, how much charge I have to pay? Can anyone tell?
80 rupees.
Huh?
80.
80. We'll calculate that one. What is the total rate here now? 140. Okay, I will write 140. What happened? Okay, this one 140. 140 rupees कितने किलोमीटर को पे कर रहे हैं हम? 70 kilometers. Total kilometer is 70 here now. Okay, into how much, up to what kilometer we have to consider? 40 here now, up to 40 here now. What is the rate now? 70 into 2 ja, how much it is? 140 here now. 2 into 40, that is
80.
80 rupees we have to pay here. Like that, this distance is there, that is called total distance of bus traveling, but this distance is the traveling by you here now, and this is the total charge of the bus here now. So up to Mohol only we can calculate. Like that, the voltage drop here now, total 70 meter length cable is there. 70 meter length cable is there here now. So the voltage drop across that 70 kilometer is 140 volt is there. 140 volt is the voltage drop across the length for 70 meters. Okay, but I want the voltage, unknown voltage, up to for 40 meter only. Up to for 40 meter only here now. So 140 divided by total voltage is, that is 140, divided by total kilometers, that is 70 meters, into the 40 meters we have to multiply here. That is called 80 volts we are going to get here. So for that reason, this is the formula for the sliding wire control or potentiometer. The voltage drop we have to measure here. You have to measure here. Is it clear?
Yes, sir.
So next topic will go the Crompton's type potentiometer. एक minute. So next is that is Crompton's type potentiometer here. I think you have studied this one, all of you. Yes? Yes or no?
Yes, sir.
Same diagram, whatever previously we have discussed about the sliding wire. So sliding, what we have done here now, this is the sliding contact we have used here now. The wire what we have used, uniform wire, that uniform wire we have used in the circular now here. This sliding wire, it may connect here, here, whatever it may. It has 200 studs, it has here now. The 0 to point volts, but each point we are going to vary for 10 ohm it is there. The resistance of this total resistance is 10 ohm is there. The range of this one is 0 to 0.1 is there. This is the sliding wire. It has a dial switch. This is the dial switch we are going to consider here. From varying this dial switch, we can vary the resistance here now. Each step, it has 10 ohm here. Now total 15 steps are there. What is the total resistance? Each step, each dial, it is a 10 ohm. Okay, total 10 dials are there. Sorry, 15 dials are there. 10 into 15, how much it is? 150 ohms resistance it is now. Total resistance of this one is 150 ohm is there here now. So the range of this dial switch is 0 to 1.5 here. One dial, it is nothing but 0 0.1, 0 0.2, 3, 4, 5, 6, 7, 8, 9, 1, 1.1, 1.2, 1.3, 1.4, 1.5 here. Total 15 steps are there here. This is the dial switch we are going to use here. So here the battery supply we are going to use as usual. This is the rheostat we are using to limit the current here now. So 10 milliampere working current we are passing to this sliding contact here now. The sliding contact we are going to consider. Again, we have connected a galvanometer and the standard cell is there. It has two terms here also. Here the calibrate, the upper side it is going to consider as calibrate, and this terminal it is going to consider as operate mode here. Here, if it is under operating mode, then we have to calculate here unknown EMF, we can measure here. If it is connected to the calibrate mode, then we have to provide the standard voltage here. But to calculate the unknown voltage, we have to, according to the procedure, we have to compare with the known value. How we have to compare that one? The unknown EMF is correct or not? By using this one, we can calculate here. Here the dial switch is there. It is a dial switch only, na? Here 130 ohm I am applying here, means that is 1.3 volt is there. Yes or no? Here voltage also they have given. Yes. So here the sliding contact is there. Suppose I have connected here. This it has also given voltage only. How much this voltage is there for from here to this point here. This much only it is going to consider here. If the null detector is there, we can compare that one. That is called Crompton's type potentiometer, or this potentiometer is also called as laboratory type potentiometer. Also, we are going to call that one. This potentiometer is also called as laboratory potentiometer. We are going to call here. This type of potentiometer is used calibrated dial resistors and a small circular wire of one or more turns, thereby reducing the size of instruments here. Now we are going to use this circular wire we are going to use, and that is small circular wire, and it has calibrated scale here. Now this is 0 0.0001, 0.0002, like that it is going to use. That is scale is also there here. This circuit, it is a simple laboratory type potentiometer here. ऐसा हम straight भी use कर सकते हैं, but the size is going to increase of that one. The instrument size is going to increase. For that reason, we have kept in the compact size only. We are going to use this circular slide wire we are going to use here now. And this type of we are going to use as, what is that one? Laboratory type potentiometer we are also calling. We are going to call this one here now. There is one dial switch with 15 steps here now. This is the dial switch. It has 15 steps are there here now. 0, 0 0.1, 2, like that here now. So each step, it has 10 ohm resistance here. Here they have written here upper side only, dial switch 15 steps of 10 ohm here now. 10 into 15, that is called 150. That is the total volts here now, 150 ohm. The total voltage drop across this one is 0, 0 0.1 is there. 0 0.1 into 15, that is called 1.5 only. 1.5, that is called 0.1 into 1.5, sorry, 15, how much it is? 1 into 15, how much?
1.5.
1 into 15 is 15 and 0.1 into 15, that is 1.5 here now. So the total voltage is 1.5 here now. There is one dial switch with 15 steps, each step having a precision resistor that is called 10 ohm here now. There is a large single turn circular slide wire here now. This is a large single turn circular slide wire is there. So the resistance of the slide wire is, this total resistance is 10 ohm is there here now. This is the 10 ohm here now. So the dial resistor have the value of 10 ohm each here now. It is 10 ohm each, and thus the dial has total resistance of 150 ohm. This they have mentioned here now. This is IA pitch over here. This is 150 dial here now. So this is slide here now. The slide wire resistance is 10 ohm only total. So the working current we are considering here, how much it is? 10 milliampere we are going to consider here now. Therefore, each step of dial switch corresponds to 0.1 volt here now. Here 10 milliampere is there. Here 0.1 dial voltage is there here now. Example they are going to consider. The slide wire is provided with 200 scale divisions here now. See here, इधर 0 है, इधर 1 है. इसका बीच में 200 scales are there here now. इसको 0.00001, 0.00002 like that. Here up to 0.1 they have used 200 scale divisions they have used here now. It is divided into 200 here now. So 0.1 volts, the total voltage is 0.1 here now. 0.1 divided by 200, how much it is? Anyone, can you tell me? 0.1 divided by 200. That is, we have already calculated here. See here, 0.1 divided by 200 is 0.00005 here. So each scale, it is going to distribute into 0.0005 volts here now. One step ko 0.0005 volts, another step ko 0.0005 volts. So it is up to 200 points are scales or divisions are there here now. 200 divisions are there here now. So by doing this one, it is quite comfortable to interpol readings up to 1/5 here now. Here 0.0005 means 1/5 only, 1/5 of the scale division, and therefore with this potentiometer it is possible to estimate the readings up to 0.0001 that we can estimate the readings we can estimate here now. So the potentiometer is provided with the double through switch which allows the connection either a standard cell or an unknown voltage to be applied to the working circuit. See here, double switch means this one is DP-DT we are going to call that one. Double pole, double through here. Here one pole is there, here second pole is there. एक switch operate किया तो दोनों pole operate हो जाते. So double switch is there, double pole switch is there here now. So one is connected to the standard cell, another they are telling that one unknown EMF. Standard cell, it is connecting nothing but calibration mode here. If the switch is connected to this one, it is a calibration mode. If a switch is connected to this one, it is an unknown EMF mode here. The potentiometer is provided with a double through switch which allows the connection either the standard cell or unknown voltage to be applied to the working circuit here. So the key is this key K we have used here now for the protective K, and protective resistance is used in the galvanometer circuit. This one is connecting to the sliding control, that is sliding contact it is going to connect. Here one more resistance they are going to use here now. Why this resistance they are using? Anyone, can you tell me? You are telling that one you have already studied this one. What is the purpose of this resistance? So what will happen? Because of this, without this, there is a large current, immediately it will flow through the galvanometer. That is, galvanometer is nothing but very sensitive here now. So it will suddenly we have applied means it has a chances of damaging. For that purpose, what they have considered, this resistance name only they have given as protective resistance they have considered here. If this switch is open, so current will come up to here it will come. Here there is a open switch means the current will flow to this one is how much it is, 0 or infinity for the open switch. For the open switch, the current flowing in the open circuit or closed circuit? Current open circuit में flow होता है क्या नहीं?
No, sir.
No. So the current flowing through 0, then all the current will flow here only. What will happen? Because of this, the current will limit here now. High value of resistance we have used here now. Current is inversely proportional to the resistance. So higher resistance is there, means small current it will flow through the galvanometer. So for the small current it will start to operate here now. After some time, what I will do, I will close this switch here now. I will close this switch here now. So it will act as a short circuit. Short circuit means the resistance is almost zero. Resistance is zero means then all the current will rush to this side here, no? So current flowing through this resistance will be zero on that condition here, no? Because it has very high resistance, so it will come to the normal position. For that reason only, this resistance is protective resistance. We have called that one. That is called protective resistance. So this is the working of how it is going to operate here now. See here, the combination of dial resistors and a slide wire is set to the standard voltage. We have set it to the standard voltage here now. Suppose the value of EMF of the standard cell is 1.0186 volt. We have set it here now. This standard cell value is so this one, suppose this standard cell voltage is 1.0186 volt is there here now, and the dial resistor is put at 1 volt here now. Here 1 volt they have kept here now. This is 1 volt here. 1.2 is there. This one, the dial is kept at 1 volt, and the slide wire is put at 0.0186 here now. Somewhere here 0.0186 they have kept here now. It has 200 divisions, no? For that reason. Then what will happen? The switch is thrown to the calibrate position. It is already connected to the calibrate position, and the galvanometer key is tapped here. Now the galvanometer switch is switched here now. Then tapped through a rheostat is adjusted to zero deflection here now. By varying this rheostat, we have to set this one into zero galvanometer null detection. We will start that one. So for the protection purpose, we have used the protection resistance we have used here. At the balance or null point is approached, the protective resistance is shorted so as to increase the sensitivity of the galvanometer. Initially, we are going to pass the current here now. So after some time, if the null is achieving, then what will happen? I will close this switch. Then again, I will vary this sliding contact and I will achieve the null position here now. So we can measure the unknown voltage. We can measure here now. How we are going to contact this one? We are going to vary this one here, means from this sliding contact we can measure the value here now. We can get the confirmation here now. After completing the standardization, the switch ESC is thrown to the operate mode. Next, what we will do? This switch is connected to the operate mode here now, connecting the unknown EMF into the potentiometer here now. With the protective resistance in the circuit, again with the protective resistance we are going to use. As the balance is approached, the protective resistance is shorted here now. Again we are going to balance mil gaye, then short karte. The value of unknown EMF is read off directly from the setting of dial adjust wire here now. This wire adjust is there. It has range of 0.1 volt is there, 0 to 0.1 here now. So ye dial it is having a scale also here now. From this one we can measure, we can compare this unknown EMF directly here. Can get the unknown EMF here now. So the standardization of the potentiometer is checked again by returning the switches to the calibrate. If it is correct or not, to check that one again we can shift the calibration mode and we can calculate this one here. Can calculate the value here now. So it completes the DC potentiometer here now. This is the Crompton type. We are going to call, also called as, Crompton has derived this circuit here now. For that reason the name came Crompton type of potentiometer. That is the DC potentiometer only here now. So it has some applications. We can use this DC potentiometers. For finding out the unknown voltage, we can measure here now. To do the calibration volt, we can do the calibration of voltmeter, we can do the calibration of ammeter, we can do the calibration of, if the, what is the formula for the power? It is the product of voltage into current only, na?
Yes, sir.
Yes, sir.
Here, if we are doing a calibration of voltage and current here now, so P equal to VI only. So P equal to VI. So wattmeter also we can calibrate here. We can calibrate the wattmeter also here now. If wattmeter we are doing here now, next V equal to, what is the formula? V equal to IR. V equal to IR into I here now. So that is called I square R. I square R. Now we can calibrate resistance also here. The resistance also we can calculate. So wattmeter is nothing but power only. We are measurement of power also we can measure. If we are calculating voltage and current, then power also we can measure this one. These are the applications of DC potentiometers. These are the applications of DC potentiometers. So it completes the DC potentiometer part. So in the tomorrow class, we'll start the AC potentiometer sessions. We'll continue over there. Rule number 7, rule number 11, 17, 19, 20, 27, 30, 31, 34, 36, 37, 38. If anybody is there, you can tell yes. You can tell yes. Rule number 7 nahi hai. Rule number 11. No. 17, 19, 20. Rule number 21. 21, are you there? Rule number 21 also absent. Okay, please present 23. Rule number 24. 27, 30, 31, 34, 35, 36, 37. Anybody is there? 35 is present. Okay. So we'll stop here only and we'll continue in the next class. समझ में आ रहा है क्या नहीं? All of you are getting?
Yes, sir.
Okay.